Every website can be split up into two parts, the front end and the back end. The front end is what you see on your screen, like the pictures and buttons. And the back end is what saves and manages your data on the web page. For example, if you're on Amazon.com, the back end will store your order history, your profile, your load search results, and many more. In this video, we are going to take a look at the technologies that are used in the back end of a web application, and in another video, we will explore the front end technologies. As an example, let's say we are on Amazon.com and we do some shopping, and now we are ready to make an order. When I click on the pay in my currency, what happens? We're going to start from the ground up. Any computer that is connected to the internet, including your computer and my computer, can send a message across the internet to another computer that is also connected to the internet. So, to put it simply, Amazon has a computer somewhere in their office building, and our computer is going to send a message continuing our order to the Amazon computer. In this scenario, the computer that is sending the order is called the client, and the computer that is receiving the order is called the server. But before this happens, computers can't receive messages from the internet by default. We have to program them to receive messages. To do this, we need a backend programming language. Almost every programming language has a feature that can turn a computer into a server and allows it to receive messages. Popular backend languages are JavaScript known as Node.js, Python, Ruby, Java, and C#. However, using a backend programming language by itself, it's actually really complicated and difficult. It requires a huge amount of code. There are two tools that we use to help with this: a backend framework and a package manager. A backend framework is used to create a server much easier and with less code. Each backend programming language has a few different frameworks to choose from, but the most popular ones are Express for JavaScript, Django for Python, Rails for Ruby, ASP.NET for C#, and Spring for Java. In the backend, we also use a lot of code that other people have written known as packages. This helps us do common tasks like sending emails, formatting date and time, validating user input. We typically use a lot of packages in our backend, and in order to install and manage all these packages, we use something called package manager. Each language has its own package manager: npm for JavaScript, pip for Python, bundler for Ruby, NuGet for C#, and Maven for Java. These are all the technologies we need to create our backend server. The next challenge we have is we need a place to store the data for our web application. Going back to our Amazon example, data could mean the user data, like the login information, order history, as well as all the products that are being sold on Amazon, the price, the description, and the reviews. In order for us to store this information, we use a database. A database helps us store and manages data. It is just a piece of software that usually runs on a different computer. And we have to do some configurations for our backend to communicate with the database. The most popular databases are MySQL, Postgres, and MongoDB. So if you are just starting out, this is basically all you need for the backend. You can build most of your project with just a server and a database. For example, here is how our Amazon scenario could work. When the customer places an order in the client side, the front end sends a message containing the order to the server. The backend then saves the order to the database. Once that is done, the server then sends back a message to the front end confirming the order was created. The message that the front end sends to the backend is known as a request, and the backend acknowledges the request and sends back a message to the front end known as a response. This process is called a request-response cycle, and this is generally how web application works. Now that we have seen the overall flow, we are going to take a deep dive and take a look into what's inside a request. Here is a simplified request to create an Amazon order. If you read over it, you can see it's actually easy to understand. We have the item that we ordered, the user ID, and some other information about our Amazon order. At the top, we have the type of request, the domain name, and the URL path. This describes where the request is going and what type of request this is. Amazon, the company, has bought the domain name amazon.com, and they've configured it so that any request going to amazon.com will be redirected to their server in their office building. So that is why we are sending the request to amazon.com. The type and the URL path identify what kind of request this is. So in this example, it is a post request to a /orders. In the backend, we use our programming language and framework to define what type of requests are allowed and how we should handle this type of request. For example, we can allow a post/order request, and whenever we get orders/ a post request, we will create an order using our programming language and then save it to our database. We can also allow a get/order request, and in this case, we will retrieve the order history from the database and send back a response to the client. In order to get a single order, we can also allow a get/order request and also /ID to get a single order. Another example is the delay/order request. This is where we will cancel the order. So these different types of requests that the backend allow is known as an API, an application programming interface. The API is one of the most important concepts in the backend programming. If you send a request that is not allowed by the API, the backend will respond with an error. So we mentioned earlier that we can identify requests using the type and the URL path. There are several types that we can choose from, such as post, get, put, patch, and delete. And the URL path can be anything that we want. So, in this example, why do we choose the post/order request? This is just the naming convention for our request, and the naming convention is known as REST. REST simply means representation state transfer. In REST, the type of request has a special type of meaning. So, post means to create something, and in this case, post/order means to create an order, get means to get something, put means to update something, patch means to partially update something, and delete also means to delay something, and so on. An API that uses REST naming convention is known as REST API. REST is the most common conversion that we use for our APIs, but there are several other conversions that we could use. One of them is called GraphQL, which uses post/GraphQL for all our requests, and another one is also known as RPC, which uses post and a more detailed URL path, like post/create order or post/get order history. So that is what a request is and an API is, and what REST means. Now let's talk about infrastructure. Nowadays, instead of companies buying their own computers to run their websites, they rent computers from a cloud computing company. The biggest cloud computing companies are AWS for Amazon Web Services, GCP for Google Cloud Platform, and Microsoft Azure. The basic idea of a cloud computing is you are renting a bunch of computers. This is known as infrastructure as a service. Behind the scene, AWS has a giant powerful computer, and inside its software, it is running many small computers. We are actually renting one of those smaller computers. These smaller computers that exist inside the software are known as virtual machines. So, in order to run our website, we rent a virtual machine from AWS to run our backend, and we also rent another virtual machine to run our database. Another problem that we have to solve is scaling our website when the internet demands go high. With cloud computing, we can set up multiple virtual machines running the same backend code, and then we can set up a special virtual machine in front of them. This is called a load balancer. A load balancer will distribute internet evenly across the backend virtual machines. To scale down our virtual machines, when the internet traffic goes down, the load balancer will do this with ease. This is a lot easier than having to buy your own computers, where if the demand is low, you still have the physical computers to pay for. But we still have another problem. We now have a lot of virtual machines that we need to create and set up. This takes a lot of time and effort. Cloud computing companies offers another service called PaaS, a platform as a service. A PaaS just let us upload our backend code and it will set up all the virtual machines, including the load balancer, and integrate everything for us. The three most popular PaaS are Elastic Beanstalk for AWS, App Engine for GCP, and App Service for Microsoft Azure. The next concept we are going to take a look at is microservices. Let's say that our backend contains code. The code saves order to the database, charges the user's credit card, and then send an email confirmation. In the real world, this backend could be a millions of lines of code, so we can split this up into 3 code bases. Each code base would have their own backend, each with a load balancer, and sometimes their own database. So when we need to send an email, our orders backend will then send a request to the email backend, which will then send the email. So splitting our backend into separate backend like this is called microservices. This helps us keep our code base smaller and more focused. Each microservice does not have to use the same programming language and a database. One microservice could be using JavaScript and MongoDB, and another microservice could be using Python and MySQL. So now, to drive the point home, there are companies out there like AWS who have already created an email service. So AWS provides an API for sending emails. So instead of us creating our own microservice, our backend can just send emails via Amazon SES. When a company provides a backend and an API that an application can use, this is called a SaaS, software as a service. Pretty much everything you do in backend that is complicated, there is probably a SaaS company out there that already provides that service. And you can just use that service instead of building your own microservice. So these 3 concepts we just looked at, infrastructure as a service, platform as a service, and software as a service, are the 3 foundations of cloud computing. These days, most companies use cloud computing to run the backend of their website instead of buying and managing physical servers themselves. So in the final part of the few minutes we have here, we will talk about extra tools that helps makes our website even better. Docker is like a magic box that packs our code so it works the same on any computer. Redis is a super fast helper that remembers things our website uses a lot so it can get them quickly when needed. We might also use tools like RabbitMQ, which help different parts of our website talk to each other. To manage Docker boxes, we could use Kubernetes. These extra tools makes our website run smoother, faster, and helps us fix problems more easily. So these are all the backend technologies we covered in this video. So if you are just starting out, you mostly need to know how to use cloud computing, a backend framework, and a primary database. Thanks for tuning in. I'm Code Janitor, and I'm dedicated to helping you master the art of clean code and robust code. I believe that a well-designed backend is the cornerstone of any great tech career. Share your thoughts in the comments below and join me next time as we continue to decode the codings.